Hey everybody, welcome to Multiplying and Dividing Rational Expressions, section 9.4. So in today's section we're going to continue with those rational functions we've been working with, and when I say rational I mean it can be written in fraction form, but today we're going to be simplifying them, and we're going to be using lots of fractions. So to start off with, let's do some review of working with fractions. So review. If I'm multiplying, multiply straight across. 3 times 2 is 6. 4 times 5 is 20, and then reduce. Now a technique that we're going to be using today is, I call it cross canceling, not cross multiplying, but cross canceling. And what I mean is, instead of doing this, if you can see on top and bottom that something can divide out and cancel, you can do that before multiplying. So here I know that 2 divides into 4, and that would reduce to 1, and that would reduce to 2, and so now on top 3 times 1 is 3, on bottom 2 times 5 is 10. I'll talk more about that as we go along. Dividing, remember, when you divide fractions, first fraction stays the same, second fraction turns to the reciprocal, and you multiply. And now let's employ this cross-canceling thing I was talking about. So first I see 3 and 3, and it has to be one thing on top and one thing on bottom, because when I'm multiplying fractions, they're all together anyways because they all multiply together. So it's kind of like I'm pulling out a common factor. So I got a common 3 on top. That simplifies to be 1 when I divide by 3. Divide this by 3 is 1. Okay? And then I can see 8 and 4 both can be divided by 4. So divide by 4 is 2. Divide by 4 is 1. So now on top, 2 times 1 is 2. On bottom, 1 times 1 is 1. 1, or just 2 is my answer. Let's try the same strategy with this next one. So think in your mind, what on top and bottom has a common factor that can be pulled out? I immediately notice 5 and 10 have a common factor of 5. So divide by 5 is 1, divide by 5 is 2. Alright, what else has a common factor? Let's see here. 4 and 16 have a common factor of 4. So divide by 4 is 1, divide by 4 is 4. 1 times 1 on top, 2 times 4 on bottom. If you got more than one thing, like right now, just the divide by part is flipped. So here that would flip to be 7, 6. This part just stays normal though because it is multiplied, not divide right there. Alright, now I want you to try for a second and see if you can cross cancel anything before multiplying this through. Alright, and then let me tell you something. If I divide the top and bottom by 3 here, I have used the 3 already. I can't divide by 3 again. So only one of the 3's gets canceled out, not both of them. Here I divide by 7. So on top I've got 3. On bottom, 5 times 2 is 10, times 2 is 20. Alright, let's talk about what it's going to look like when we have simplified form. So simplified form for what we're doing today is if the numerator and denominator have no common factors. If the numerator and denominator have no common factors. So notice what I was doing earlier in the warm-up. I was trying to take out what could be divided in top and bottom. That's called a factor when you divide it off. And one quick comment I want to tell you about, if I have things like this multiplied by something, very different situation than if I have things like this added. If you have it multiplied, I can pretend like the c is a common factor and divide it out, and that would be equal to a over b. If I have a plus sign though, it can't be simplified. This is very, very key. I would say number one mistake I see every year is students forget that if it's a plus sign, you can't cancel it. Now let me show you why, okay? Let me show you why. Let's say that a and b are 2 and 4, or no, 2 and 3, let's say. Okay, so let's say that a and b are 2 and 3. C is going to be 4, let's say. So the question is, if I was going to multiply this straight across, I'd have 2 times 4, which is 8, 3 times 4, which is 12. That, when I simplify, that is equal to 2/3. Is that the same answer I would get if I canceled before multiplying. So if I said, okay, 4 and 4 have a common factor of 4, I can divide those off first. Is that the same thing as what I started with? Yes. Okay, so check. It works to cancel if you're multiplying. But notice this guy, 2 plus 4 is 6, 3 plus 4 is 7. That's 6/7. That's very clearly not equal to 2/3 if I try to just cancel those out. So it doesn't work. It's not equivalent. You can't cancel if there's plus signs. Come back and look at that whenever needed, because that is really, really important. So if it's multiply, you can cancel. If it's plus, you can't cancel. All right. To start off with, you're going to be given some things that look very similar to what we did in Chapter 7. So actually, to start off with, this is not really new material. What we're going to do is we're going to simplify our variables and simplify our numbers. And if you prefer, some students like to multiply the variables together first just to figure out how many are on top and how many are on bottom. Here's what I mean. I got x squared times x cubed on top. Remember that when I have x squared times x cubed, you add the exponent. So that becomes x to the 5th. And then on top, I've got y times y squared. So it's really like y to the 1st, so that's y cubed. On bottom, I got plain x all by himself, and then y cubed times y, so y to the 4th. All right, so that's my variables. Let's look at our numbers. If you want to employ the cross-canceling thing, I'm looking for a common factor. So is there anything in common on top and on bottom that I can pull out? And it has to be one on top, one on bottom to pull something out. I immediately see, okay, I got a 5 and a 10. Those can be divided by 5. So divide by 5, divide by 5. And then how about the 6 and 2? I can divide by 2. So divide by 2 is 3. Divide by 2 is 1. So now 1 times 3 is 3. 1 times 2 is 2. The only thing I need to do to finish this problem is to figure out how these x's and y's simplify. And I hope you remember from Chapter 7 that when I have on top and on bottom, you subtract them. So 5 subtract 1 is x to the 4th on top. 4 subtract 3 would be y to the 1st, but there's more y's on bottom, so it stays on bottom. Go ahead and pause the video and try B on your own. All right, you should have 14 over 39 y cubed for your answer. Last but not least, let's look at C. So I specifically put this problem in here because I wanted you to, again, remember, I cannot cancel if there's a plus sign. So I cannot immediately cancel this. But here's what I could do, and this is going to lead into what we're doing with example 2. If I can rewrite this as something multiplied by something, something multiplied by something, then I can cancel. So here's what I mean. X squared, I could rewrite that so it's x times x. And then on top, I can actually factor this like we hopefully have been working on. I can factor an x out of there, so I've got x times x plus 5. And now, because it has a multiply, now you can cancel that x and that x. And so my final answer is x plus 5 over x. And again, you can't cancel if there's a plus sign. So now, we're going to be multiplying and dividing with factoring, and most of them are going to be the 2 parentheses type, but there are going to be some more greatest common factoring problems. And I want to tell you something. If you are super good at factoring, you may secretly enjoy this. So if you're going along here and you're like, wow, this is actually kind of fun, you can tell me tomorrow in class, because I secretly enjoy this as well. I think it's pretty cool. All right, here's why. I'm good at factoring. I've had lots of practice over the years. What we're going to do is we're going to factor the top and factor the bottom using the strategies that we have been working on all week. Remember that if I have just 2 pieces, it's usually that special difference of squares situation. And my goal here is to rewrite all of these so it's something times something. Because remember, if it's something times something, that's when you can cancel. And now I'm going to factor the bottom to be x plus 2x minus 2. And the top, I'm looking for 2 things that multiply to be negative 12, add to be negative 4. So I'm thinking x minus 6, x plus 2. And now this seems a little weird, but this entire piece is being multiplied by this entire other piece. So as long as it's a whole chunk, it is legal for me to cancel out the whole chunk because it has that parentheses. It counts as like a number because I could put something in for x and turn it into a single number. You know what I mean? And so your final answer is x minus 6, x minus 2. And we are done. There's no common factors. And remember, I can't cancel it any further because it's just a plus and minus sign. So basically every single time, this is what it's going to be similar to. So let's think about factoring this next one. Think in your mind, okay, what multiplies to be negative 6 but adds to be negative 5? I'm thinking x minus 6, x plus 1. And you know what? I'll give you a secret. These are meant to cancel. So if I have a x plus 1 or a x minus 6 on top, it's very likely at least one of those are on bottom. In this situation, it's another difference of squares 1. So x minus 1, x plus 1. And then whatever parentheses is in common on top and bottom, that counts as your common factor. And so x minus 6 over x minus 1 is my final answer for example B. Moving on to C, I want to show you what it looks like when you have a situation where you're factoring out a greatest common factor. And notice each one of these blobs we're going to have to factor. This one down here is the only one we don't have to deal with. And another thing I want to tell you is sometimes when I'm doing these problems, I don't rewrite it on the side. I like to just write it above it. That kind of makes it a little faster. So let me show you what I mean. Let's do this blob down here first because I think that looks easy. In my mind, I'm like, okay, what multiplies to negative 3 but adds to be 2? What multiplies to negative 3 but adds to be 2? I'm thinking 3 and negative 1. So what I do is I sometimes just write it down there and then cancel that out. You don't have to do that, but it's a shortcut I like to use. Alright, I'm going to do this blob in the upper right hand corner next. I now want two things that multiply to negative 6 but add to be a 1x. And here is where, if you are someone who still struggles with factoring, the only reason you might be lost right now is you don't know how to factor. For those of you who are good at factoring, I'm probably going way too slow for you. Alright, again, the lower right hand blob doesn't have to be changed. So let's look in the upper left. It's not the two parentheses method because x is not something squared. If it has a subtract sign, both of those have to be squared to follow that special pattern we used in A and B. So then next I want to think, is there a common factor I can pull out? And I think there is, and it is 4x. So if I pull out a 4x out of both of these, 4x divided by 4x is 1, negative 4x squared divided by 4x is negative x. Alright, now let's cancel what we can. I see a x plus 3 on top, x plus 3 on top. I see a 4x on top and a 4x on top. And then you might be wondering about this guy. Now I want to tell you that as is, these are not the same because this one has a negative x and this one has a positive x. There is something we can do about that though. Let me write down what our answer is at this time before moving on. So right now on top I got 1 minus x, x minus 2. On bottom I have x minus 1. Now here's the deal. This seems a little weird, but right now these parentheses don't cancel. I actually can factor out a negative 1 in order to make these match. Here's what I mean. When I factor out a negative 1, 1 divided by negative 1 is negative 1. Negative x divided by negative 1 is positive x. So what I have essentially done is now, if these are in a different order, but negative 1 plus x is the same thing as x minus 1, right? Agree with me? Same thing? Yes? Alright, so now I can cancel them because they're the same. And here's my final answer, negative 1 times x minus 2, or negative x plus 2. Thanks for listening, and please join me for 9.4 Part 2.